Hello and welcome back to yet another episode of Learning with Junaid. Today we are going to be talking about an interesting algorithm. It's called as the binary search. So the binary search algorithm is a very interesting algorithm, a very frequently asked algorithm as well. So it's good to know the implementation of a binary search algorithm. Most of the interviews that I do, or most of the interviews that I have experienced, they've always asked me about binary search algorithm. So most of the other recursive algorithms are just an extension of binary search algorithm, in a way that, if you're working with trees or graphs, you will see those are just an extension of something very similar to what we do. So the binary search algorithm, as the name says, it's an algorithm that talks about binary, that's 2. So if you have an array like this, always the binary search algorithm divides this array into 2 halves. This is the first half and this is the second half. So that's the binary search algorithm. The recursive algorithm is actually we keep dividing the further. If I'm working with this part, I keep further dividing it into 2 again and again. So until I found the element, I have to find the element that I'm looking for. In simple terms, if I have to write it down, I will write it like this. The precondition for a binary search algorithm is that you are working with a sorted array. So in this case, if you see, I have a sorted array. The post conditions or the implementation of an algorithm is divide, or for example, find the middle element of the array first. If the middle element is equal to the value that you are searching for, then just return that middle index. Okay, third case, if it is not, so what do you do? So now you have the third part. If the middle element is less than the value that you are searching for, that means if your middle element is example 45, if it is less than the value that you are searching for. So let's say that you are searching for 65. You want to find out what is the index of 65. What is your middle element? It is 45. If your middle element is less than your value that you are searching for, that means your value is in the second half. The value is in this part. Otherwise, then the value is in the level above the middle element. Otherwise, if the middle element is greater than the value that you are searching for, then the value is below the middle element index. For example, if the value that you are searching for was 14, so what is your middle element? 45. Is your middle element 45 greater than 14? Yes. So that means your value will be starting from here to here. So you don't even have to iterate through this, or you don't even have to take this into consideration. So you divide your array into 2. You either search here or you either search here, and you further divide this into 2, and you either search here or you either search here until you find the element. So that's a binary search algorithm. So now let's see how we can implement this algorithm. Very simple to do. All you have to do is go ahead and write a method. So let's say I'm just going to define a method here, system.out println, and I'm going to say search. I'm going to pass this entire array, and let's say that I'm searching for 65. I want to know at what index 65 is. So go ahead, create this method. So this returns a integer because we are working with an index. I'm going to return a 0 for now, right? Okay, so remember the conditions. So the first thing is you take the array and you divide this array into 2 so that you get the middle index. How do you do that? You actually okay, so this is not an implementation method. I'm going to call a different method called binary search, and I am going to pass the array. I'm going to pass the starting index. I'm going to pass the end index, and I'm going to pass the value that I have to search. The value is, let's say, 65. Okay. So the implementation of binary search, we will do it in this method. So now we will follow our algorithm. The algorithm is what? First, find the middle element. Okay, so let's go ahead and find the middle element. What is a middle element? So to name, for the sake of clarity, we will name this as starting index, and then we will say ending index, just to be clear. So we have to actually take the median. The median is what? Starting index plus ending index. You take this and you divide it by 2, then you get the median. Simple. Okay, so now you go, you have an array, you have take the value from an array of median, and we will now implement if the array of median is less than the value that I have. Okay. Or even before you do that, if my array of median is equal to the value that I'm searching for, you don't even have to do any sorting at this time. Just return the index of this median. For example, if you were searching for 45 here, it would just return 45. That's your middle element, right? Otherwise, what you will do, you will make a check if my array of median is less than this value. What do you have to do? So if your array of median, that is the value that you are searching for, is less than the value. So what is your array of median right now? It will be 45. This is an element. Is it less than 65? Is 45 less than 65? Yes. So in this case, I have to discard this first part. I don't need this at all. I know my element will be here. My element will be here. So I will make a recursive call to binary search, and I will say, hey, binary search, this is my original array, but the starting index for you now is not 0. The starting index for you is here, 56. So the starting index will be median plus 1. Does it make sense? Because you know the median value, it's less than the value that you're searching for. In our case is 65. So you know that this element has to be in this block, not in this block. So you will just increment your starting index and say my starting index will start from here, go and start, and your end index will obviously be at whatever was your array dot length. and then you pass your value. Otherwise, so same thing you will do, but in this case, what you will do is, the only difference that you will do is, so for example, if you are, instead of searching for 65, if you are searching for, let's say, 14. So 14 is in this block, and this is your median, right? So your starting index would be 0, or whatever was the starting length that got passed here, but your ending will be median minus 1. So your ending would be at here. So you're saying just go and search for the element from here to here, because I know that element 14 will not be here because it's less than 45. So you will say the ending index for this is median minus 1, and you will go ahead and you will say return. We'll go ahead and you'll say return. So let's try it with 65 first. Oh, I'm going to. So you're just going to go ahead and let's say run it. So you're saying 65 is at index 6. So let's go ahead and try for 14. 14 is at index 1, which is actually what is the binary search implementation. So now the good thing about binary search algorithm is that the implementation, since it's recursive, it runs in 0 log-n time. So you have to just remember it runs in O log-n time, which makes it one of the most efficient algorithms. So all you have to do is divide the array into 2 and then just do a recursive, and you have to change based upon, like, if it's less, you know where you are going to be searching. If it is more, you know where you are going to be searching. So that is a very simple algorithm to implement, very easy and very important. If you can just practice it once, I think you will never be able to forget an algorithm, binary search. And that's it from me. If you have any questions, please don't hesitate to write a comment. If you have still not subscribed to my channel, please subscribe to my channel, and I will see you next time. Until then, goodbye. Thank you and stay safe.